U.S. has already spent more than $10 billion on storage, and they're incurring $2 million a day for added storage cost on average. And so for deep isolation, when we look at that with our techno-economic reviews that we've done in the U.S. and overseas, depending on the size of your reactor and how much fuel and other factors, the type of geology you've got, pricing can vary, but it looks like it's a savings of more than half. At the bottom line, it could be even more than that depending on your situation. And so there is the opportunity to save billions of dollars.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. Today on the Clean Power Hour, deep isolation. For decades, the U.S. has failed to establish a permanent large-scale repository for spent nuclear fuel, with Yucca Mountain stalled progress as a case in point. My guest today, Rod Baltzer, CEO of Deep Isolation, aims to solve the long-duration nuclear waste problem. Deep isolation is using off-the-shelf technology, boring technology, and applying it to this nascent industry, which could, if successful, save taxpayers billions of dollars. Welcome to the Clean Power Hour, Rod Baltzer.
Thank you, Tim. It's a great pleasure to be here.
I really appreciate your time. And this industry is near and dear to my heart because I grew up in Albuquerque, New Mexico, fighting a nuclear waste depository called WIPP in southern New Mexico, which had some fundamental flaws. It was a salt depository. But anyway, I also live in the most nuclearized state in the country called Illinois, where 40% of our grid power comes from nuclear. And currently, many people don't realize this, but the spent fuel is just piling up on site at these nuclear power plants around the country. And what we want to do is put it deep underground in a very secure geologic formation that'll keep it safe away from humanity for thousands of years. And we haven't succeeded in doing that for a variety of reasons. It's a complicated story, but tell us, Rod, how you came to the nuclear waste industry and what is Deep Isolation trying to achieve?
Yeah, I came through to nuclear waste just by blind luck. So I'm actually an accountant. I'm a CPA by training, and came up through the finance side of the organization. I worked initially at a low-level radioactive waste company, and eventually became CEO there. We sold that company to private equity, and they brought an executive team in, and so I joined Deep Isolation after that in 2018. Started there as their chief operating officer, and got promoted to a CEO last year. So I've been here about 8 years now. Nuclear waste is one of those things where you don't think about it a lot unless you're in the business or around it or whatnot. It's safely stored, but it's also one of those that, because it is safe and nobody really thinks about it, there's not an impetus toward disposal, and that's costing us as taxpayers billions of dollars a year. So
Yeah, and
isolation came along to change that.
that was a big takeaway from me from our pre-interview, where you told me about this reality of the DOE, the U.S. Department of Energy, has to pay utilities to store the waste on site because there's a contractual relationship between the government and the utilities that they are going to ultimately create a depository, and they haven't been able to do that. And so they're having to pay the utilities to store the waste on site, which it has two problems as far as I see. It's expensive and it's not necessarily safe for the public. Why don't you just further explain that problem, because that is really creating a market for deep isolation?
Yeah, so when utilities go to operate a plant, they have to sign what's called a standard contract with the Department of Energy. And that basically says that DOE will take their waste and dispose of it. And those standard contracts all got signed a long time ago. And they all said DOE would start picking the waste up in January of 1998. And that didn't happen. DOE thought they'd have a repository by then, but they don't. And so utilities have sued the Department of Energy, said, hey, you've got a partial breach of contract here. You were supposed to pick it up and you didn't. That's forced me to expand my storage. So on a nuclear power plant, you've got spent fuel assemblies. They go into a pool, and those pools were designed for a certain period of life. But without having any kind of place to take it for the next step into a permanent repository, they had to put it into dry cask and put it in storage next to their plants. And so almost all the utilities in the U.S. have dry cask storage sitting next to them, even utilities that have decommissioned the reactor, and all that's still sitting there is the dry cask storage of the spent fuel. It is safe. You can walk out there. I've walked out on pads. You don't get a whole lot of dose. It's very robust concrete outer packages with a steel liner inside of it. And eventually those could be moved or transported to a repository, but we don't have one. And so the concern is, well, how long is it going to sit there? And some of these have been there for more than 60 years already. And so the question is, after 100 years, do we have to repackage this, or what can we do about it? So deep isolation has come along with our borehole technology to say, we don't think you need to be the repository for the entire nation. You could put these in place just for your utility, just for your power plant in that community, and put it deep underground instead of in storage above ground next to the reactor.
Mm-hmm. And what is the potential cost savings for the DOE and ultimately the taxpayer who's footing that bill when we, transition from scenario A, the current scenario of storing the waste on site, to scenario B, where we're putting it in capsules, putting the waste in capsules, and then shoving the capsules into a tube or a borehole that has been, and we'll get into this technology deeper as we go, no pun intended. But what is at face value, the potential savings for the United States?
Yeah, so the U.S. has already spent more than $10 billion on storage, and they're incurring $2 million a day for added storage cost on average.
Mm-hmm.
And so for deep isolation, when we look at that with our techno-economic reviews that we've done in the U.S. and overseas, depending on the size of your reactor and how much fuel and other factors, the type of geology you've got, pricing can vary, but it looks like it's a savings of more than half as a bottom line. It could be even more than that, depending on your situation. And so there is, the opportunity to save billions of dollars. So when you talked about Yucca Mountain, that national repository for all the waste would have been around $100 billion back in those days. And so when you talk about saving half that cost, that's $50 billion, which is not enough to get us out of debt in the U.S., but it's not insignificant.
Yep. And let's just paint a further picture of the industry. How many plants are there operating in the U.S.? And it's a little bit of a dynamic time in the nuclear industry. The U.S. government is trying to create a resurgence, and we have officially announced the reopening of some plants that were previously closed. I don't know if we've announced any new builds, but and you probably know that statistic. But what's the state of the industry, and then of those plants, how many locations as they exist would be appropriate for your technology?
Yeah, so when we look at the U.S., there's I think 70 some odd sites that have 90 some odd nuclear reactors at them. Typically, they'll have one or two reactors. A couple of them have three or four, and the last one that was finished was the Vogtle plant number four, and so that wrapped up not long ago and was connected to the grid. When we look at new ones, there have been announcements recently from Westinghouse that they were going to build, I think it was 10 new plants based on some of the executive orders and other things from the administration. And then we've also seen, I think it's Fermi Energy out in Amarillo, former Secretary of Energy Rick Perry's group that said they were going to build 4 new nuclear reactors as well as a lot of gas to power AI. So I think there's been a lot of kind of announcements of those types, and then also a lot of AI data center agreements between some of the small modular reactors and advanced reactors, as well as these big gigawatt plants.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. So plus or minus 70, you said 70 sites in the U.S.?
Sites, 90 reactors, yeah.
And of those 70, how many would be appropriate for deep isolation?
Yeah, we looked across the U.S. just at a high kind of desktop level, and it looked like about 80% of those had a nice shale or crystalline granite kind of rock beneath it. And it looked like that might be something that would be interesting to drill. We'd have to do site specific to be sure. And of course, the community would have to be willing to do something like that. But we would say that most of them, you typically are going to try to site a nuclear power plant in a seismically stable area away from mineral extraction opportunities, and similar for our repository as well.
So 80%, that's a pretty good number. And what is the geologic formation that you are ideally seeking?
Yeah, we look at a couple of them. The shale, a clay layer, something like that, that's that we drill in opportunistically right now with directional drilling. Those look really good. They're a little more shallow, and they've got really good permeability qualities, so that you have an isolated area that's been out of touch with the surface for more than 1 million years. We also look at granite. We've done studies in both of those rock types. That's been a traditional mine repository rock. It's a harder rock, so it's a little more costly to drill through that. But it is something that's available, and particularly it could be deeper or near surface depending on where you're located. The third type would typically be salts, and so we looked at that briefly, but we haven't done a lot of experiments or testing, a lot of analysis in that one yet.
So let's get into the technology and the business case a little more. You're using directional boring, which is currently used in oil and gas. So you can think of the St. Louis Arch, okay, upside down, going down into the earth. So you're boring a hole that is 18 inches in diameter down into the Earth's crust. How deep are you going, and is it truly off the shelf, or are you having to create some new version of directional boring technology?
Yeah, for us, it's like the logo behind me. So we would go down and turn. It's not that sharp of a turn, and then go horizontal. It could be slanted or other properties, but the idea was let's use this directional drilling because that allows you to stay in a formation. So once you identify that formation that looks suitable for disposal, you could follow that as long as that formation lasts. Generally, for us, we're looking at a kilometer, 2 kilometers deep in the same laterally. So that's roughly a mile, deep and a mile laterally. And that's looks like that would provide sufficient safety. When I say sufficient safety, the regulatory standard out there that most people abide by would be about 10 millirems, which is a chest X-ray. We'd be 1,000 times less than that as we've analyzed that. So this looks like it's very safe. It puts it deeper than a mine repository. We're about twice as deep. They're about 500 meters or so, and so we're twice as deep. And that added transport time and just distance from surface allows us to get those kind of safety performance.
So you said a mile deep and a mile wide.
Correct.
Yeah. And what is this is a little geeky, but what is the temperature when you go a mile deep?
Yeah, it definitely gets warmer. And so we've got to be mindful that we don't want to boil water at that depth. And so as you go deeper, you also have more pressure, and that allows you to keep from boiling that water and creating a gas at that depth. And so when you look at 100 Celsius being the boiling temperature of water, we go down at depth, we'd be around 160 in the kind of natural environment. And
Celsius?
And we would add Celsius.
Okay.
And then we would add another 40 degrees Celsius with our payload. So we'd be in that kind of 200 range, except the pressure at that kind of depth makes the boiling point of water about 300 Celsius. So we're still well below that boiling point of water down there.
Okay. And so you're taking fuel rods, you're putting them in a stainless steel casket, you call it, or a capsule?
A canister.
Yeah. Canister, yep. And then you're shoving it like a pill. You can think of just a pill, right? Or a small elevator. What are the dimensions of the package, and how many are you putting down? And I guess, how does this translate for every borehole that you're able to build? How much of the waste are you able to store?
Yeah, so when we build these boreholes, they're about 21 inches as we drill them into the rock at depth. And then inside that, we would put about an 18 and a half inch casing inside, and we'd cement that casing into the rock to make sure it stayed in place. Inside that would be our canister. That canister is about 15 inches in diameter. And inside that is one spent fuel assembly. It's about 12 inches on the diagonal. It's a square assembly, but 12 inches on the diagonal. And so they nest together in that configuration. And these canisters are about 16 feet long. And so you can put a lot of them in that space. And I said a mile before, depends on your site and how much space you have. They can be shorter. But if you generally think of about 200 or so in a borehole, that wouldn't be that hard to do. For a gigawatt nuclear plant that operates for 60 years, we'd need about 20 boreholes to hold all the nuclear fuel from that lifetime of production.
Oh, 20 boreholes. That sounds totally doable. How long would it take to build 20 boreholes?
So it takes about 45 days per borehole to construct, and I have not done the math on how much total that is.
Sure. Now, you've recently done a reverse merger. You raised $33 million through that. What is the near-term plan for deep isolation? What are you going to market with?
Yeah, this fundraise allows us to go out and do the full-size at-depth demonstration. So what we've done already is a small scale. We took a 3-foot-long canister that was about 5 inches in diameter down an existing oil and gas well. We released it there. We pulled everything back up to show no wires were connected, and then we went back and retrieved it. For us, we need to show that this can be retrieved if we need to. We've also done large scale, so we've produced a couple of these canisters already. We call it a universal canister system, UCS. And so we've connected this with casing up at the surface, but we haven't done it at depth just due to the cost of drilling that out at that size. And so we've done kind of full scale at surface, small scale at depth. I need to do full scale at depth. And that's the majority of this funding being used toward that purpose. And what our customers have told us is this is important to them, that they want to see this happen. They want to bring over their regulators, their communities, and others so they can kick the tires and really see how this works and understand that better.
Yeah. And what is the industry's response to your technology?
Yeah,
I mean, I think of like there's obviously the plant operators, but there's also the DOE. Like, they're footing the bill for this storage en masse. What are the experts saying about deep isolation?
When I first got started at deep isolation, boreholes were, I'll say, on the fringe of the discussion. And there had been some discussion back in the 50s, I guess, early 80s, but the technology for directional drilling hadn't really taken off yet. And so the technology has now leaped ahead of where we used to be and what we thought we could do with directional drilling.
Yeah.
And it's really opened up a lot of things for us. And so when deep isolation came and kind of re-looked at boreholes and started doing some of these reports, the industry, I think, has started to take a little bit more notice of that. It's become a little bit more in the mainstream. We see there's cooperative research projects at the International Atomic Energy Agency that talk about borehole disposal specifically. So that has helped a lot. We've also had good support from the Department of Energy. Their Advanced Research Projects Agency for Energy, ARPA-E, has given us about $6 million worth of grant funding that's helped us design this universal canister system and look at some of these new advanced reactor fuels like triso pebbles or molten salts or other things. And how would you dispose of that? How would that be compatible with our boreholes and canisters and things? And so we've done a lot of work with some of those new nuclear companies coming online and the work there.
Compare and contrast deep isolation's approach, if you would, to the Yucca Mountain approach.
So for Yucca Mountain, it was an 18-foot wide tunnel, basically, that you could drive a train through, and it was carved into a mountain. It was in a tough formation geology-wise. They had to put a lot of engineered barriers in. They wanted to make sure water didn't get into the canisters. They have to manage the heat and thermal loads as well as the radioactive aspects of that. And so you were carving this facility out of a mountain. You needed ventilation and other things for workers and all the worker safety for being underground in a mine repository. And it was for the entire nation's waste. Nevada does not have any nuclear reactors. They have had lots of nuclear testing there at the site, but they haven't had any nuclear reactors. And so there was a lot of political pushback at that time. For deep isolation, ours is a 21-inch borehole that you can fit with drilling equipment. We don't need ventilation. Nobody's going to be downhole. As these get spaced out in a horizontal configuration or even vertical, it's canister end to canister end. And so you don't have them lumped together. It helps with the thermal properties and managing some of that heat load and other aspects. And so it actually makes management of some of that radioactive waste better. And so we've been able to look at both deep isolation as a standalone, put it next to a reactor or have a regional repository or something like that, where it's smaller scale, so you don't take the entire nation's worth of waste. And we've also looked at it as a synergistic aspect if you did need a mined repository, which the U.S. will. We have some waste that just won't fit in a borehole. But you could take some of the higher heat generating waste or the nastier stuff out of it, put that in a borehole and make the rest of the operation simpler and reduce the life cycle costs for the entire program.
Yeah, so it's really kind of apples and oranges, right? Yucca Mountain is a central location, a very large central location, a kind of a man-made cavern in a mountain, and you would have to take all the waste from the industry and truck it or train it across the country. And that was also, I think, one of the problems is getting permission from all these authorities having jurisdiction states, counties, etc., and that gummed up the system. So this is more of an on-site but permanent solution by putting it underground. It does concern me having all this waste at surface for a variety of reasons. It could leak into surface water or groundwater if the containers leaked. I sail on a nuclear power plant lake, and I really appreciate having this power plant 30 minutes from my home because of the sailing. And of course, there's all kinds of other recreation going on there at Clinton Lake. But the thought of all the waste piling up on site really doesn't suit me very well. I'd rather have it pushed underground as long as that's going to be a stable formation and nobody else is going to drill a hole into it. What are some of the other challenges that we haven't talked about that you have to overcome in order to get this technology embraced en masse?
Yeah, the technology's there. So as we talk through with our drilling experts and supply chain vendors and others, oil and gas is used to taking things from a pad and deploying them downhole. Nuclear is used to taking things out of a spent fuel pool and moving them to a pad. And so we're combining both of those where we take it to a pad, put it into the drill hole and deploy it downhole, and we can do that safely. So the technology, I don't know that there's any cutting edge there. It's the public perception, which we think having a modular solution, being able to do just your power plant and not the entire nation's, particularly smaller countries. We're dealing with some in Eastern Europe that are interested in this, and it seems like something that will get embraced further there. But that all makes a difference. We also, I think, on the regulatory aspect, they've been focused on mine repositories for such a long time. Looking at borehole takes a different way to look at it. And so having that be more technology neutral, I think would be really helpful for deep isolation. We've been working with the International Atomic Energy Agency and others. We've had visits with the Nuclear Regulatory Commission on what our technology is, what it does, and how it operates, just making sure that as we get into those kind of stages, we're not unknown to them.
What else should our listeners know? I'm keen to see this pilot get done. Congrats on the raise. That's huge. As my listeners know, I am a skeptic of this new movement to promote nuclear only because it takes a long time to build a nuclear power plant and it's expensive. But we still have to solve the existing waste problem. We have an existing fleet. We can't remain in denial that we have a fleet of nuclear plants that are operating, generating waste. We need to solve this problem. And so that's why I support you and this effort. We need to solve the long duration waste problem. What else should our listeners know?
One, I want to echo your comments. Yeah, whether you believe in nuclear or not, we've got a waste issue out there because we haven't disposed of any of this. And it's going on 70 years. And so we need to not kick the can down to the next generation. We've got technology. We've got the ability to do this. And if we disposed of it, we would save in the storage cost, and this would be better financially for everybody to get started now. So that would be my encouragement. As people do look at new nuclear, make sure you don't forget about the back end. If you plan this stuff out now, it will make your life so much easier when you do go to decommission or dispose of that waste, that you package it appropriately. Put it in our universal canister. We call it a universal canister because you can transport it, you can store it, you can put it in a mine repository, or you can put it in a borehole. So you don't know what you want to do with it yet or where it's going to be. It doesn't really matter. Just put it in that canister so you don't have to repackage it. It'll literally save, in the U.S., to repackage everything we've done would be $20 billion. And that's just the time. It's not the radioactive dose. And so just encourage people to think about that as you go through.
And does Deep Isolation own IP around this universal canister?
Yeah, Deep Isolation has 87 patents that are issued. They're not all about the universal canister. They include the full life cycle, from how do you characterize a site or drill the well and what does that look like, the canister and retrieval and emplacement, the post-closure plugging of that well. So it's the life cycle, but we do have some specific on the universal canister. We've also got license agreements available if there's interest out there from others on this.
And I guess what would be the next phase of success for you, Rod, at Deep Isolation? You've got this, call it startup funding, right, for this large, at scale pilot. What is the next stage of your growth and development if you're successful?
Yeah, so stage one is get the demonstration done. We want to do both the subsurface, looking at that. That's the most critical piece. And then add in the surface facilities as well. How do you get it from a transport, whether that's, a couple of 100 yards from the reactor or traveled over the road or over the tracks downhole, and demonstrate all of that. The next would then be starting to engage with the regulatory authorities on a license application to actually get this done.
Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. All right. Well, thank you so much, Rod Baltzer, CEO of Deep Isolation. Check out all of our content at cleanpowerhour.com. Follow us on YouTube. Reach out to me on LinkedIn. I love hearing from my listeners. Check out my new book, Wired for Sun. Just go to cleanpowerhour.com, click on book. And with that, Rod, how can our listeners find you?
Yeah, go to deepisolation.com. So we're also on social media and others, but our website is deepisolation.com. And we've got a lot of videos and papers and studies and other things out there. So I think you'll find it pretty interactive and interesting.
All right. Well, I'm Tim Montague. Let's grow solar and storage. Take care, Rod.
Thanks, Tim.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.